Welcome to the class today. So today we will do remaining portion of mechanism of organic reactions. We have seen last time substitution reaction, free radical, nucleophilic substitution reaction. Electrophilic substitution reaction is not mentioned for this particular chapter, and so that you will be doing later on and more in detail in class 12. And so now we will do the next your type of reaction, that is addition reaction. Addition reaction. This is of three types, and all the three types you have to do. The first is nucleophilic addition reaction. And since it is addition reaction, so the substrate has a double bond, and that double bond will be between dissimilar atom. Addition reaction, is shown by unsaturated compounds. Unsaturated compounds, which have double bond or the triple bond. So nucleophilic is shown by those unsaturated in which multiple bond is between dissimilar atom, either this or you may have this. So when these compounds undergo addition reaction, it will be nucleophilic addition reaction. So how the reaction is carried on, one example we will take. This is aldehyde combining with HCN, hydrocyanic acid, and we get RCH OH NCN attached here. This is called cyanohydrin. Aldehyde we have started, so aldehyde cyanohydrin, and now the mechanism. The mechanism of this reaction is the substrate first. This undergoes electromeric effect. You know the electromeric effect. Pi bond will break, and a pair of electron will be free, will be transferred to more electronegative atom, and we will have the new electronic condition, that is lone pair and a negative charge, and here will develop a positive charge. This is a species form, and this is your first step. In the second step, this species which is formed, that comes in the contact of addendum. HCN is ionic compound, so cyanide part, nucleophilic part, this is having hydrogen ion and cyanide ion. So both will be attacking to this. Positive will attack here, negative will attack here, but both these parts, this is nucleophilic part, this is electrophilic part of addendum. So both these nucleophilic and electrophilic will not be attacking simultaneously, but one by one. So one will go first, the other will be later on. So which out of the two, the nucleophile or the electrophile, which is moving first, that you have to decide here. So here if you just see that oxygen is electronegative, it will receive electrophile, but oxygen already is having a lone pair, and so it is quite stable, is not in need of electron. And if you look for carbon, carbon is electronegative but is having deficiency of electron, and so this carbon is in more need of electrons, so carbon will be inviting very strongly this nucleophile. That's why a nucleophile will get a chance to attack. So what is the reason? This carbon is called carbonyl carbon. This carbonyl carbon is having positive charge, or you can say carbonyl carbon is having deficiency of electron. That's why nucleophile will get chance to attack first. Hence it is called nucleophilic addition reaction. So here RCO lone pair negative, and here H is already there. The CN will be attached. This is step 2, and in the next step this hydrogen ion will be attaching here. So in the third step, if we continue, then I write up there the third step The third step is your RCHCNO. This is so plus hydrogen ion, and that will be forming the main product. OH will be attached, H is there in CN. So this is your third step. So this way you have carried on this, and so important thing you have to remember that when unsaturated compound is having your multiple bond between dissimilar atom, and then I explain to you why nucleophile will be attacking first and electrophile will get chance to attack later on. Now the second kind of addition reaction is your electrophilic addition reaction. This is shown by those unsaturated compound which have a multiple bond between similar atom. This is an example of alkene. So remember that alkene and alkyne, multiple bond is between similar atom. So they undergo electrophilic addition reaction. So when this will be combining, this is substrate is combining with HBr, you will have CH2, single bond CH2, H attached there, Br attached there, or maybe H or Br there. But for this you will have to see several examples of alkene. I give you another example of alkene, that is CH2 or CH3CH, double bond CH2. Here also alkene, but this alkene is unsymmetrical. This is unsymmetrical and this is symmetrical. This is important thing you need to remember for electrophilic addition. Symmetrical means when the multiple bond, either side of the multiple bond, same number of carbon atoms are there. Like if you take this example, this is also your symmetrical alkene. This is butene 2 and this is also symmetrical alkene. And this is unsymmetrical. 1, 2, 3, 4. This could also be your unsymmetrical. So butene 1, butene 2 is symmetrical, butene 1 is unsymmetrical. So we'll study two cases when substrate alkene is your symmetrical, and the second case when alkene, that substrate, is unsymmetrical. And here this is your unsymmetrical. Addendum is also unsymmetrical. Means what? Both parts, electrophilic, nucleophilic part, both are different atoms. So both are unsymmetrical. So this is symmetrical, but this is unsymmetrical. This is unsymmetrical, but and this is also unsymmetrical. And here it could be your, this is your symmetrical, and this you can also take symmetrical. This is symmetrical, and here this is your unsymmetrical, and this you can take symmetrical. So we have two cases. One is that addendum is symmetrical and addendum is unsymmetrical. When both of addendum substrate. When substrate is symmetrical and substrate is unsymmetrical, but in both the cases addendum is symmetrical. The other case is that this is symmetrical, substrate is symmetrical, here substrate is unsymmetrical, but addendum is symmetrical. So when we have this case or this case or this case, writing product will not be a problem. In this case, product will be 1, 2, 3, 4. Double bond has turned into single. So one Br will be attached there, one Br here. And we will have CH, CH, CH3 and CH3. Not difficult. One bromine to one this carbon, the other bromine there. And in this case also the same. double bond has turned single, so one Br here and one Br here, so this is CH2, H2 and H3. So which I have taken here, there is no problem when this is symmetrical or unsymmetrical. Then symmetrical, this is symmetrical, and here this is symmetrical, this is unsymmetrical. So when substrate is symmetrical or unsymmetrical and your addendum is your water symmetrical, then you have no problem. Then symmetrical, if you have the substrate and addendum is unsymmetrical, then also you have no problem in writing the product. But in case of this, when substrate is unsymmetrical and addendum is also unsymmetrical, both of them are unsymmetrical, then you will have a problem. What problem? There are two products expected. One is this 1, 2, 3, 1, 2, 3, and double bond is turned to single, and here so remaining hydrogen let me insert, and this is CH3. So when HBr is attacking, so possibility is what? That is, if this is breaking, here you may have H and here you may have Br, and here you can have H and here you can have Br. So two kinds of product can be expected if you see that. So this is your 2 bromo and this is 1 bromo. This is number 1 first product and this is second product. So first product is 2 bromo propane, and the second product is 1 bromo, or simply you can say bromo propane. Okay, so 1 and 2 bromo propane. So when it is electrophilic, it is found that this product is the main product. This is main product and this is the byproduct, and remember that. So how to decide that whether this will be, we will have a 2 bromo as a main product and not 1 bromo as a main product. For that you will have to take help of Markovnikov's rule. Markovnikov's rule. This is for electrophilic addition. Electrophilic addition is for the double bond, triple bond between similar atoms for alkene and alkyne. So what is Markovnikov's rule that you see? That is electronegative part of the addendum. If HBr is the addendum, then electronegative part of the addendum is Br. So the electronegative part of the addendum goes to that olefinic carbon. You have studied earlier, I have mentioned earlier also, the carbon atoms which are linked by double bond. This is alkenes are having common name olefin. So these carbons are called your olefinic carbon. Or this bond, double bond is also called olefin bond. So olefinic carbon, so electronegative part of the addendum goes to those olefinic carbon atom, that olefinic carbon किसी एक पे जाएगा, olefinic carbon atom which has lesser number of hydrogen. So this is having only 1, this is having 2, this has lesser. So electronegative part will come over here. So if it is going to come over here, negative part, so this should have a positive part. Okay, so how the mechanism will be carried on? HC double bond CH2, so bond will break like this, electromagnetic effect, and we will have a CH3 CH single bond CH2 lone pair positive, and here will be the negative. So here this will be formed here, and then your HBr in the next step, your HBr, this is your first step, and so in the next step CH plus CH2 will be attacked by HBr and Br will be coming CH3, CHBr will be coming here. We'll have CH2 and H will be coming here. So in this case, what is there? This is electrophile, this is nucleophile. So in this case, what is happening? Electrophile is attacking first. So this Br is not attacking first, this is remaining plus, and here water H plus only is attacking in the second step. This is because of the orbital orientation. And so remember that in this case this is there, and so we have got a carbonium ion formed. Now if I just do the other way, CH2 here double bond, and if it breaks like this, so what you will have CH3, CH single bond, CH2 lone pair negative, and here will be the positive. So H will be attacking here, so we will have this as carbonium ion. So this is secondary and this is primary carbonium ion. So secondary carbonium ion you have studied is more stable than primary carbonium ion you have studied earlier, and any species which is more stable will stay for a longer time in the reaction system. So here secondary carbonium ion will stay for a longer time, so reaction mechanism will be favored by this, and that's why electrophile attacks first, and hence this reaction is called electrophilic substitution reaction. So this is your step 2, this is step 1, this is step 2, carbonium ion you can write under this secondary, and this carbonium ion is now reacting with Br minus, and we get CH3, CHBr and CH3 as a step 3. So you should know why in this case electrophile will be attacking first. Electrophile will be attacking first because the secondary carbonium ion which will be formed, that is more stable. So remember that. So Marconi-Combs rule, according to Marconi-Combs rule, the reaction proceeds. Now the third kind of addition reaction is free radical. Free radical addition reaction. This is for unsymmetrical alkene addition reaction. So unsaturated compounds have to be there, and this free radical is popular for your alkene and alkyne which are unsymmetrical. This is unsymmetrical and this is also unsymmetrical. Both of them are unsymmetrical. So you may be thinking it is like the previous electrophilic, but it is different from electrophilic. If we take a peroxide here, if you get a word peroxide, this peroxide is not an organic peroxide, not an ordinary peroxide like hydrogen peroxide. Instead, this peroxide is a benzoyl peroxide. This is benzoyl peroxide. So when this is there, peroxide is there, then reaction will proceed according to anti-Marconi-Combs rule. What is anti-Marconi-Combs rule? Electronegative part of the addendum will go to that olefinic carbon which has more number of hydrogen atom. So in this case we will have CH3, CH single bond, CH2, Br will be here, H will be here. And so in this case 1 bromo, the previous one you saw 2 bromopropane was the main product, but in this your 1 bromo. So if this word peroxide you don't find, in this you 2 you have here, then the product will be, if this is not there, then the product will be 2 bromopropane. But if you find this word peroxide or this benzoyl peroxide on the arrow, then it is your 1 bromo will be the main product, and the mechanism will be your free radical. So I show you the mechanism for this. The mechanism in the first step, benzoyl peroxide, you can also write a benzoyl peroxide like this, C6H5CO. These are the 2 molecules, oxygen and bonded. Okay, this is benzoyl peroxide. In the presence of sunlight, you know, free radical reaction takes place in the presence of sunlight. Both parts are identical, so it will break homolytically and we will have benzoyl free radicals 2 moles. This is first step. Now this benzoyl free radical, one of the molecule I take. You have studied earlier also in, if you don't know then you remember, carbon with 2 free oxygen is never stable. It releases automatically carbon dioxide. Since in the reaction system already a free radical is there, you have studied, when a free radical is present in the reaction system, then the next steps will be done by homolytic fission, not by heterolytic. So this bond will break from here, CO2 is released and we will have phenyl free radical. So now sunlight is not required, only in the beginning to initiate the reaction sunlight is required. Now this phenyl free radical, this will attack HBr addendum, and HBr, although here it is both of these atoms are not having same negativity, but because of already existing this free radical, here the bond will break homolytically and we will have H dot and Br dot. So H dot and C6H5 dot will form benzene and Br dot will be formed. This is step 3. Now in the next step, that is the substrate CH3 CH double bond CH2 plus Br dot, bromine free radical, which is obtained from addendum, will be attacking this, and this bond, single bond, means pi bond and sigma bond. So one bond will break, and here when this will break, the electron will not be transferred, but it will be breaking homolytically again because of this free radical. So we will have CH3, CH, CH2, and we will have one dot here and one dot here. Br dot will be combining here and will be forming CH dot. This is your secondary free radical. And you know secondary free radical, if this would have attached here, then we would have got primary free radical, and you know primary free radical is not that stable as the secondary, and so reaction will not be proceeding through unstable free radical. So here will be dot, here will be Br. So this is secondary free radical, remember that this is formed, and this is the main intermediate. So if you see here, we have one, this free radical, benzoyl free radical, second is phenyl free radical, third is bromine free radical, and fourth we have got, that is your propane free radical, or you can say alkyl free radical from the substrate. This is not from the substrate, this is not from the substrate, this is not from the substrate, but this is from the substrate. So I have mentioned to you earlier, if you remember, that is a free radical or the intermediate, carbonium or carbanion. Free radical, which is here, compound which is formed, this is formed, this one is formed from the substrate. So this will be considered as intermediate. These free radicals will not be considered as a intermediate. Maybe asked in examination, which one will be the free radical out of these 4. And so this is the free radical form, and why only this? Because this is more stable than the primary. Now in the next step, now you know that these steps will be, these are starting the reaction, so this is initiation step, and these steps will continue propagating the reaction, so this will be propagation step. And now in the next step what will happen, this will be attacking another molecule of HBr. So I write the next step, that is your CH3 CH dot CH2Br will be attacking HBr. HBr, because of this free radical, will be breaking homolytically. We'll have H dot, Br dot, H dot will be combining here, and we will have CH3, CH, CH2, Br and H and Br dot out. You may ask why not Br dot will be combining here. Will not be combining because this bromine which is attached having 3 lone pairs, another bromine cannot come closer, repulsion forces will be acting upon, and so therefore hydrogen that is having a dot, that is free radical, that will be combining. So we'll get the product 1-bromopropane. So this is the mechanism of a free radical addition reaction. Now we come to the elimination reaction. Third kind of reaction, that is your elimination reaction. Elimination reaction is taking place in a saturated and unsaturated compounds. So unsaturated means which are less unsaturated, means only in double bonds, not in triple bond. Triple bond is highly unsaturated. So it is taking place in alkene and in your alkene or any compound which has a single bond, not always alkene, maybe alcohol also, maybe your alkyl halide or something. So which have only single bond, organic compound which has only single bond will show elimination, and organic compounds which have a double bond will also show elimination, maybe alkene or aldehydes or ketones, etc. So they will be showing elimination reaction. This is one thing you need to know. And this elimination reaction, if I just take example, this is of 2 kinds. This is of 2 kinds, alpha elimination and beta elimination. And remember always, whenever elimination takes place, it is not only one atom which is being eliminated, removed, but always there will be 2 atoms that will be out from a molecule. So if alpha elimination I am talking means removal is taking place, that is removal of atom is taking place only from alpha carbon. If you have this compound, methyl chloride, so first carbon to which halogen, you know that a carbon which has a functional group or substituent attached, that is called alpha carbon. So from this alpha carbon, this chlorine will be out, this H will be out as HCl, and so this we will have left with one this bond here, one this bond here, and so a negative charge here, because this is leaving, hydrogen is leaving its electron here, and therefore what will happen, this is gone, this electron is gone with chlorine. So we have got that chlorine from here and H from H has left his electron, but the chlorine has taken the electron. That's why we show here a lone pair negative charge. This is called carbene. This is not in your syllabus. Alpha elimination is not in your syllabus. It is very rare. And so when both atoms are removed from the same carbon, that is alpha carbon, it is alpha elimination. Beta elimination example, if you see, this is ethyl alcohol. This is ethyl alcohol. This carbon is alpha carbon to which a functional group attached. This is beta. So one group will be out from alpha, the other group will be out from beta. So that elimination is called beta elimination. So we will have CH2, double bond CH2, and water is out. So here just you see this reaction here. As I told you, that is, this is your saturated compound has turned into unsaturated. If you start with a double bond, the compound obtained with a triple bond. So saturated will be converted into unsaturated, and less unsaturated will be converted into more unsaturated. This is about beta elimination, and these elimination reactions are named as dehydration. You know very well, dehydration means removal of water. Then dehalogenation. Dehalogenation means removal of halogen as HX So always two atoms are out. So dehydration means H and OH out. Halogenation 1H and 1X is out. D, like this many are there. Dehydrogenation, removal of hydrogen. Debromination, removal of bromine, and so on. So the word D means removal. Okay. Now this beta elimination is of two kinds, E1 and E2. Like SN1 and like SN2, which we have done earlier. Unimolecular elimination reaction, bimolecular elimination reaction. So it is like SN1. So SN1 reaction is shown by tertiary alkyl halide. This I have taught to you. So E1 is also shown by tertiary alkyl halide. This is similarity. Then this is shown by primary alkyl halide. This is tertiary alkyl halide and this is primary. Primary shows SN2. So AN2 is also shown by primary alkyl halide. So this is similarity. Then this combines with KOH. This also combines with KOH. So whether it is SN1 or E1, it will be combining with KOH or NOH, a strong alkali. Whether it is E2 or SN2, it will be combining with KOH. It is your similarity. But what is the difference in case of SN1? This is aqueous. If it is aqueous, it is SN1. But when it is alcoholic, it is E1. Here it is aqueous, then SN2. And when it is alcoholic, then it is E2. So this is the difference, you remember? So through this you can cancel reaction. If it is your given Rx plus KOH alcoholic, then reaction will be your elimination. And if it is given aqueous, then reaction will be substitution. Tertiary, if it is there, then E1, and if it is primary, then it is E2. Secondary alkyl halide undergoes both. That is like SN1 and SN2. You know that. Secondary alkyl halide undergo SN1 and SN2. So secondary alkyl halide undergoes E1 and E2 both. So what was the condition for SN1 for this? When this was polar, then SN1. When it was non-polar, what? Solvent. Then this was SN2. This I have explained to you. But in case of E1 and E2, when it is non-polar, then it is E2. And when it is polar, then it is E1. This is polar, then E1. This is non-polar, then it is E2. So remember that. And I show you the reaction now. So what is the reaction? Your CH3, CX plus KOH aqueous. One this example I take. Another example I take CH3, CH2, OH plus KOH alcoholic. Elimination, so it has to be alcoholic. So first see this reaction. OH from here. This is OH and it's reacting with KBr if you take. Okay, so what it will be? Let me teach that first, then this will be, you will be able to understand. So this KX will be combining. When KX will be combining, the bond will break and a carbonium ion will be formed. So here also a carbonium ion is formed like SN1. And so KX will be forming, here will be the positive charge generated, CH3, C plus, and X is out because of this. So that X will combine with K, and now this part will be combining with OH ion. OH ion is a nucleophile, and so this will be attacking this. But before that, what will happen? Since alcohol is there, so it may not get chance to attack. So one of the hydrogen from any one of this will be combining with this and will be forming water. So 1H if it is out, so this will be balanced, and if I show here, so this is CH2, this is CH3, this is CH3, this is C, and this bond is there when one hydrogen is out from here. So that electron will be balancing this deficiency and a double bond will be formed. So what do we obtain in this case? In this case we obtain CH2 double bond C, CH2 double bond C, one CH3 here, another CH3 you can show here, and plus KX plus water. This is the reaction you can see here. That is, this has gone. So here is a double bond and this carbon is 2-methyl group. This carbon is 2-methyl group. So halogen with K and one hydrogen in which will be forming water. So how this is different? So the main thing is you have to compare SN1 and E1 and SN2 and E2. So SN1 first is your what? Tertiary alkyl halide, primary alkyl halide. Second is your what you call it, carbonium ion is formed, and here it will be your transition state will be formed. So these are the similarity of E1 with SN1. These are the similarity of E2 with SN2. And what is the difference? The difference is of aqueous and alcoholic. If it is aqueous, it is substitution reaction. If it is alcoholic, it is elimination reaction. So this part you have to do. So here finishes your this chapter, organic compound, and all the content belonging to it. And so have a nice day and all the best for your midterm examination. Goodbye.